This video will cover the topic, graphing a rational function quadratic over linear. Rational functions are defined by algebraic fractions in which both the numerator and denominator are polynomials. In this specific topic, we will focus on when the numerator is a quadratic and the denominator is linear.
I think I know what those look like, but can we see an example problem?
Let's take a look at the function f of x equals 2x squared minus 4x minus 1 over x minus 2. To graph a function like this, we need to draw the asymptotes and plot at least 2 points on each piece of the graph.
Should we start by seeing if we can simplify the expression?
That sounds like a great place to start. In this example, it doesn't look like either the numerator or denominator can be factored. We also see that nothing in the numerator or denominator will cancel out, so we now know our function is in simplest form. Now we can find the vertical asymptote. A rational function in simplest form has vertical asymptotes at the zeros of the denominator. If we set the denominator equal to 0, we can add 2 to both sides of the equation, and we see that when x equals 2, the bottom expression will equal 0. Since a fraction cannot have 0 in the denominator, the graph cannot cross the line x equals 2, so this is our vertical asymptote. Next, a rational function in simplest form has a slant asymptote if the degree of the numerator is exactly 1 greater than the degree of the denominator. When this is the case, the graph has no horizontal asymptote. In our example, the degree of the numerator is 2, and the degree of the denominator is 1. So we need to determine the equation of our slant asymptote using long division. We will divide the numerator, the quadratic, by the denominator, the linear expression. If we multiplied x times 2x, we would get 2x squared. So we put a 2x on the top. Now we multiply 2x times x minus 2, and we get 2x squared minus 4x, which we will want to subtract from this original expression. 2x squared minus 2x squared is 0, and negative 4x minus negative 4x is also 0, and we'll bring this negative 1 down. We can't go any farther with our division, so we can now rewrite the function as f of x equals 2x minus 1 over x minus 2 after performing long division on the original function to divide the numerator by the denominator. In this specific sample problem, our divisor was a linear expression with a leading coefficient of 1. Because of this, we could have also used synthetic division to arrive at the same result. Now we can see that as x increases to infinity or decreases toward negative infinity, this term, the negative 1 over x minus 2, will approach 0.
If that term approaches 0, then f of x will have to approach 2x as x increases or decreases, right?
That's exactly right. So we can identify our slant asymptote as y equals 2x. Now that we've identified our asymptotes, we can place these on the graph. So we have a vertical asymptote at x equals 2 and a slant asymptote at y equals 2x. We now need to plot 2 points on each piece of the graph. This means we will plot 2 points on each side of the vertical asymptote x equals 2. Since 3 and 4 are x-coordinates to the right of the line x equals 2, let's start by finding their corresponding y-coordinates. If we plug 3 into the function, we get 2 times 3 squared minus 4 times 3 minus 1 in the numerator, which simplifies to 5, and we get 3 minus 2 in the denominator, which simplifies to 1. And 5 over 1 is equal to 5. Next, we can plug 4 into the function for x. When we do this, we get 15 in the numerator and 2 in the denominator, which leaves us with 15 halves, so our point is 4, 15 over 2. Now that we have 2 points that are to the right of the line x equals 2, we need to find 2 points that are to the left of the line. 1 and 0 are x-coordinates to the left of our vertical asymptote, so we'll continue by finding their corresponding y-coordinates. When we plug 1 into the function, we get -3 in the numerator, and 1 minus 2 is -1, so we get -1 in the denominator, and this simplifies to 3. This means that one of our points is 1, 3. Next, if we plug 0 into our function, we get -1 in the numerator and -2 in the denominator, and this simplifies to 1/2. So our fourth point is 0, 1/2. Now that we've found 2 points on each piece of the graph, we can plot our points. After our points have been plotted, we can complete the graph by connecting the points on each piece of the graph while illustrating that the curve approaches the asymptotes. And now we've completed our graph.
That seems like a lot of steps. Let me make sure I understand everything. To begin, we need to determine if our given expression is simplified. Then we identify the vertical and slant asymptotes because in a quadratic over linear function, the degree of the numerator is 2 and the degree of the denominator is 1. Next, we need to plot 2 points on each piece of the graph in order to finish graphing.
That all sounds great. Good job remembering all those steps.